Okay, good morning students. Let me continue some more properties for alkenes today. Actually, we are waiting for the offline classes to you also. And somebody asked me in the mobile about in the group about the knots of alkanes, alkenes and hydrocarbons, etc. Which we will give, definitely which will give the knots for the hydrocarbons, particularly alkenes, alkenes and alkynes and their properties and all. So we are waiting for the completion of this chapter. And after the completion of this chapter, we will be issuing the notes to all of you. Okay. Today I want to clarify certain reactions of alkenes, the chemical properties of certain alkenes. In our last class, I was discussing the Marconi-Cos rule and the anti-Marconi-Cos rule, which is also known as crash peroxide effect, which I was talking about in the last class. And today, three more important reactions of alkenes, which I am going to say to you. Students, first you will just see hydroboration and oxidation. Hydroboration followed by oxidation. That is one reaction. Second reaction is oxymercuration and demercuration. That is another reaction. And the third one is ozonolysis. That is a reaction with ozone gas. Three reactions are there, and three reactions are very important as far as an alkene is concerned. Actually, technical application is there. For the first two reactions, you will get the first reaction, you will get the primary alcohol, and secondary alcohol in the second reaction. And in third reaction, we are going to find out the position of the double bond by using ozonolysis. First, you will be getting an ozonide and ozonide on what you can say the hydrolysis. You will be getting aldehydes. So, or ketone, sometimes it is a ketone. So, that which we are going to study on first reaction. I am not going to take a lot of syllabus on today because these online classes, if I talk more, you may feel bad. So, therefore, it is better to say the most important and prompt things in my class. Today's class in particular. So, hydroboration followed by oxidation. What is the reaction? You take one alkene. Alkenes are compounds, hydrocarbons containing carbon-carbon double bond and saturated carbon. We take one example. This is propene. Propene should be taken according to the syllabus. Propene should be taken, and that's how to say. Propene you have to take and you have to treat with diborane. B2H6 is known as BH3BH3. BH3BH3 is known as B2H6. That is known as diborane. So diborane is reacting with propene in presence of THF. What is THF? Tetrahydrofuran. Tetrahydrofuran. THF is known as tetrahydrofuran. FURA. Tetrahydrofuran. So this reaction happens in the tetrahydrofuran medium. That is the medium of the reaction. So propene with diborane in presence of tetrahydrofuran, you are getting CH3, CH2, thrice B. It's a boron substituted product, and double bond is satisfied. Three molecules are reacting here. And one more boron atom actually coming out here. That means this double bond is satisfied with hydrogen. BH3 particularly. BH3, BH3. So you can see this one hydrogen atom here and one hydrogen atom here. Okay, this is satisfied, and in addition to that, three molecules are combining with boron, just like BH3. The compound is just like boron try BH3 or BF3, BH3. So like that you can see this portion is 3 molecules. 3 molecules will be here and boron here in order to satisfy the valency. Just like BF3, BH3, you can see 3 molecules of this part, CH3, CH2, CH2, because this double bond is satisfied and you are getting the compound like this. CH3, CH2, CH2 thrice now. I will show the camera near to the blackboard once again at the last session of the class. So this molecule you have to hydrolyze. You have to hydrolyze or oxidize. Oxidize and hydrolyze, that is better. H2O2, hydrogen peroxide. The hydrogen peroxide is an oxidizing agent. You have to oxidize this compound with hydrogen peroxide in presence of alkaline medium. You are getting a primary alcohol. So primary alcohol, this is a preparation of primary alcohol. Preparation of a primary alcohol. Just see the compound. Primary alcohol, CH3, CH2, CH2OH. What is this alcohol? CH3OH is methyl alcohol. CH3, CH2OH is ethyl alcohol. This is CH3, CH2, CH2OH. Methane, ethane, propane. This is normal propyl alcohol. Last class, when I was talking to you, I was given some example and wrongly I spelled the name of the compound. Actually, it was something like methane, ethane, propane. It is a propane derivative. I have written propane derivative in the last class somewhere and I pronounced it as a neutral derivative. So, sorry for that mistake. You might have noticed that last class. So, this is actually a propyl alcohol, not a butyl alcohol. So, this is a primary alcohol and it is a normal propyl alcohol. Right? Methane, ethane, propane, butane. Right? So, in the second reaction, oxymercuration and demercuration. Oxymercuration. And what is this reaction? Hydroboration and oxidation, followed by oxidation. This reaction is oxymercuration and demercuration. So this is also a typical reaction to prepare the secondary alcohol. You must know what is primary alcohol, normal alcohol. Primary alcohol is an alcohol in which OH group is connected to a carbon atom containing 2 or 3 hydrogen atoms. But in this case, OH group is connected to a carbon atom containing only 1 hydrogen atom and 2 methyl group. So whenever an OH group is connected to a carbon atom containing only 1 hydrogen atom, such alcohols are known as secondary alcohols. And there are many other definitions which I don't want to express you now. There are many other ways. But now you can see OH is connected to a carbon atom containing only 1 hydrogen atom. Such alcohols are known as secondary alcohols. So here also you have to take normal and the propene. Propene is also known as propylene. In this also propene. Propene you have to take the example. So propene is taken as an example which you have to treat it with mercuric acetate. Mercuric acetate. So this is mercuric acetate. CH3COO twice Hg. Mercuric acetate and the medium is same THF. Tetrahydrofuran and in presence of water. See the compound, propane should be taken, mercuric acid is taken in the tetrahydrofuran medium and followed by hydrolysis. And the water should be taken. And you will be getting an addition product. Addition product you can see, the double bond is cutting here, opening here, and 1 hydrogen atom is adding here, 1 OH group is adding here from this session. Followed by the water addition and all. 1 CHOH is forming here in this point and this bond is broken. And here it is CH2, Hg, COO, CH3. This is the compound. CH3, CHOH, Here it is an OH group and this is cutting open here and CH2, HgOCO. The HgOCO, CH2. That means CH3CO, you can just see CH3COO twice, isn't it? Out of that, this portion, CH3COO, that is this portion. This is adding. CH3CHOH, CH2HG, HG here, and oxygen COCH3. Oxygen COCH3. Other part is removed. CH3COOH might have been removed. I will tell you what it is. CH3CO twice Hg, isn't it? So out of that, this one is this portion is added here. Another CH3CO. You will ask where is that another CH3CO? That must have been removed as CH3COOH. From acetic acid molecule might have been removed here. Only the other portion is there, CH3COOHG. Understood the things? And this is an additional product. And this is again you have to treat with sodium borohydride, NaBH4 in presence of OH minus. OH minus means NaOH, alkaline medium. Sodium borohydride. You have to treat this compound with sodium borohydride and you are getting a secondary. Sodium borohydride is a reducing agent. So this molecule is reduced into a secondary alcohol. So in the first reaction you are getting a primary alcohol, and second reaction you are getting a secondary alcohol. This is a normal propyl alcohol and this is an isopropyl alcohol. Isopropyl alcohol. This is isopropyl alcohol and this is normal propyl alcohol. So these two reactions, hydroboration, oxidation and oxymercuration, demercuration. Oxymercuration, demercuration. Here you are adding mercury in this system and in the second step you are removing mercury. The first step is known as oxymercuration. Second step you are removing mercury from this compound, that is known as demercuration. Similarly, in this reaction you are doing hydroboration. First you are adding B2H6. Secondly you are oxidizing. Second step is known as oxidation. Two reactions you can see. There are two reactions each in each reactions. Two reactions each in each reactions. Understood? So that you have to study properly for the examination point of view. This may be one of the questions in the question paper. Alright, in the extreme right side of the blackboard, I have written another reaction which is also very important reaction, that is important property in organic chemistry, that is known as ozonolysis. Ozonolysis is the reaction of a compound, that is an alkene with ozone gas. This reaction is useful to find out the position of the double bond between the carbon atom in a carbon chain. But in this reaction there is no problem because carbon double bond is here. It is a symmetrical compound and there is no problem of. But I have to explain this one and then I have to work on unsymmetrical alkene. So in the symmetrical alkene, you can see the ozone molecule is adding and you are getting here. This is opening. I am writing here again. CH2 double bond CH2 was here and that was changed into the oxygen atom oxygen here. Another oxygen atom is adding lines. So you are getting a compound like this. This middle bond is gone and you are getting a compound like this. Ozone molecule, what is ozone molecule? O3. There are three atoms. Three atoms are accommodated in between two carbon atoms. The double bond is open and you are getting a system like this. Such a compound is known as ozonide. Such system is ozonide. Let me clarify it. So such a system is as an ozonide and it is really helpful to find out the double bond position in the ozonide. The compound is known as this ozonide. This compound is known as ethylene ozonide because you are taking ethylene and ethylene with ozone you are getting one ozonide. Ethylene ozonide. This ethylene ozonide is again hydrolyzed in presence of zinc. Zinc is the medium. Hydrolysis, you are removing this oxygen atom will go, and this is CH2O, and here it is CH2O. So what is CH2O? CH2O is HCHO. CH2O can be spelled like that, HCHO. That is formaldehyde. Two molecules of formaldehyde will be formed. I have written here. This oxygen will go HCHO and HCHO. Two molecules of CHO will be formed. That means in a symmetrical system you are getting identical. In a symmetrical system you are getting identical compounds. Similar type of compound. What compounds? Aldehydes. Okay. So in this reaction, this is a general explanation of the reaction. There is not much use for this reaction because I told you this ozone analysis is used to find out the position of double bond in organic compounds. Not only in alkenes, simple alkenes, even in bigger compounds, bigger ring compounds. You are finding out the ring system. Position of the rings, position of the double bond in the system. Maybe a ring system, open chain compound, whatever it may be. So ozone can be useful to find out, just like the X-rays, to find out the position of the double bond. So in this reaction is general. So there is not much. But in the extreme other side, I have written another reaction. That reaction was a reaction of ozone with propene. You can see here CH3CHCH2 also. You are getting CH3, CH3, CH, double bond, CH2. That is the reaction. Here it is cutting off. And here this bond is gone. Here another reaction, another addition taking place. So oxygen is handled like this. Next step there is hydrolysis with zinc and water. So this oxygen will go and CH3CHO one molecule, there is acetylase, CH3CHO one molecule and HCHO another molecule. So this part is HCHO. This is second step. Hydrolysis in presence of zinc, you are getting HCHO. In this part CH3CHO, two molecules, so two different aldehyde molecules are formed. So if you find out the products, definitely you will be getting, you can find out the nature of the parental compound, position of the double bond as well as the nature of the parental compound, which compound is taken in the first step. So structural identification, this reaction is important in the structural identification, and this reaction is very useful in finding out the position of double bond in alkenes as well as in the other organic systems, maybe a bigger compound containing double bond. We want to find out the position of the double bond. We want to find out the nature of the structure of the compound by using the ozonolysis. Ozonolysis, in both cases, this product is known as ozonide. Propene is taken, propene ozonide. There it was ethylene is taken, which is known as ethylene ozonide. But in the second step there is an hydrolysis with in presence of zinc metal. So you are getting the products, and if you find out the products, naturally you will be getting the idea about the structure of the compound. So let me conclude this class with showing the camera very near to the board so that you can once again understand the things. Today I was dealing with alkenes and their chemical properties again. First reaction was hydroboration, oxidation reaction, for which I have taken propene reacting with diborane in tetrahydrofuran medium. You are getting an addition product like this, CH3, CH2, CH2, 3 times B. Okay, that is taken again, and you are treating the compound with hydrogen peroxide, that is an oxidation and hydrolysis process. You are getting a primary alcohol, that is normal propyl alcohol. Okay. In the second reaction, that is oxymercuration and demercuration, propene again taken in presence of mercuric acetate, THF medium, and hydrolysis should be done, and you are getting an addition product like this. Addition product is like this, and that was again on addition product is like this, and that is again on reduction with sodium borohydride. You are getting a secondary alcohol. Okay, in the third reaction it was ozonolysis, that is a reaction with ozone. The simple compound is taken, ethylene is taken, and oxygen is added. In the molecule, you can just see the molecule, that is an ozonide. Again it is written like this, ozonide, and which is on hydrolysis in presence of zinc. You are getting two identical molecules, two HCHO molecules, formaldehyde molecules. Let me go to another compound, that is propene on ozonolysis. Double bond is satisfied, but double bond one or three molecule is added there in between the carbon CH2 place, which is on hydrolysis. You are getting one molecule of CH3CHO and another molecule of HCHO. Okay, students. For studying these all things, you need a book. Now, if you have any book, you can easily follow the text. And hearing me is not enough. Seeing something is very much essential for you. So you have to find out. Today I have just stopped in the class. Thank you very much.